Hey guys, my name's Lynn, head of engineering here at the DeEEP Network. I wanted to introduce myself and take some time to show you some of the things we're working on here. So my background is software development. I've been building for about 30 years. I got my start in the embedded software world in the late 90s, and then went into network applications, embedded hardware, worked in the drone space for a while. Well, DePIN really wasn't a term back in 2018, but my first sort of real-world asset, real-world devices being put onto a blockchain empowered by token economics was in 2018. We built a custom chain to a fork of Ethereum that would put drones on a blockchain, rent airspace, and had a whole bunch of token dynamics. Whenever I tell someone that we put drones on a blockchain, I always get asked, why? Why would you do that? And it turns out airspace is a really tricky problem to solve. How do you incentivize airspace and carve that airspace up and prioritize it for operations of the future? If you have a drone that's delivering a human heart versus a drone that's delivering a pizza, how do you organize priorities and schedule that flight traffic such that it makes sense for the human heart, etc.? And so our blockchain had several older rules that were FAA laws. It had versions of those built on blockchain. Every drone had a wallet, and we knew at any moment where a drone was, which events from the chain caused that drone to take that maneuver. Yaw, pitch, roll, take a picture, etc. But even takeoff and landing and a whole host of other things were controlled by signed messages that were coming off the chain. Eventually, that opportunity led me into to the gaming aspects of blockchain gaming specifically. At that time, play to earn was exploding. This is early 2021. So that led me into a fighting game franchise, very similar to Mortal Kombat. It was a play to earn. That kind of kept going. I kept going down that route in gaming, and eventually connected with some ex-Marvel and DC executives that wanted to build interactive web content. I realized building all of these Web3 blockchain gaming systems, they were all destined for the same cloud provider, AWS or Google, which is pretty disappointing. Being able to merge all the experience I had with the drone infrastructure in the beginning with some of the gaming knowledge that I acquired, I was very interested in moving back to where my core passion was, which was true decentralization. So that's a little bit about my background in building software. Hopefully it gives everyone a good idea of what I'm passionate about, where I've spent my time. It sort of leads me into what I really want to talk about, which is the tech stack that we're building here at the DeEEP Network. The stack that's going to enable us to truly decentralize workloads and software, provide security and efficiency across many types of workloads. So I'd like to go through a few of those components. We have great names for them: Riptide, Swell, ReefKeeper, Sonar. I'll go through a few of these and sort of illustrate their role in workload orchestration. One of those systems we call ReefKeeper, and ReefKeeper is our job scheduler and reconciler. It's sharded by design. It can handle 50,000+ workloads, and through sharding we're able to scale that effectively into 6 digits and beyond. It's an optimistic deployer, which has been extremely fun to build. It essentially, at a high level, deploys jobs and waits for success codes and then moves on to the next deployment. And this heartbeat that runs is able to deploy jobs very, very quickly. There's another portion of ReefKeeper that's spinning in a separate thread that is essentially a health monitor, but it's able to work in tandem with the reconciler through a really high-speed in-memory database to keep track of healthy workloads, sick workloads, workloads that are maybe in a danger zone and might need to be rescheduled, moved to another node in the network. ReefKeeper really is the heartbeat that drives orchestration. Another part of our stack that's really meant to tackle the real-time requirements that we have for the DeEEP network is something that we call Sonar. Sonar is it's written 100% in Rust. We do that for all the reasons you would write something in Rust: memory safety and speed, size, small containers. But our Sonar API essentially allows at any level in the DeEEP network a way to transmit and store data durably in an in-memory database so that we can support a wide array of client interfaces, whether it's a website, a dashboard, or other microservices in our system that require real-time information. The throughput is insane. It's super high, 50 to 100,000 transactions per second without any sort of cluster mode enabled. So horizontal scalability has been a design goal from the very beginning with Sonar. But Sonar plays a very intricate piece in status reporting. The health of nodes. It's also how we ship off dynamic information from Web3 workloads, whether this is a BLS key or any key pair or any dynamically generated information from any workload is effectively stored in a durable database, but the freshness of the data is guaranteed. One of the pieces in our stack that really is developer facing is a component that we call Riptide. Riptide is, you can think of it as a developer SDK. Essentially, it's a wrapper around a workload, say a Docker container, that maps between two different domains, semantic meanings of exit codes, of statuses, of all sorts of things. And so the process sort of looks like this. You have a workload that you want to run, and let's say it's a Docker container. You wrap a thin shell around that Docker container, Riptide, and implement a few hooks. These hooks give you access to the DeEEP network. It's essentially an abstraction layer. It's a developer-facing SDK that's lightweight, wraps your workload, and allows your domain messages, exit codes, system messages, functionality to be packaged and travel through the DeEEP network, up the stack, and end up as actionable insights inside of various interfaces. So we've talked a little bit about some of the systems that make up the DeEEP network stack, Sonar, Riptide, etc. We can take a look at this slide to see an overview of how these systems interplay together. It's fairly high level, but for the most part, most of these systems represent some state that a workload is in as it travels through the stack. Whether a workload is purchased on the DeEEP marketplace or comes from an external client or some other system from in the future, they all kind of run through the same life cycle. As we have a set of core services, Sonar, ReefKeeper, that interplay together, backed by 3 or 4 different databases, but primarily in-memory databases. We use Valkey and Postgres databases to track the injection of that workload into the top level of the system. So underneath the core services, we have another layer we refer to as the orchestration layer. There's a high-level diagram here showing how a service essentially finds its home in the DeEEP network. And there's a ton of factors we use for that. Certain affinities, certain geos, certain capacity, performance requirements. All of these add up in a formula that determines the placement and the location in the DeEEP network. Down in the Coral Reef Services block, there's actually quite a bit of testing that goes on before we run real workloads. We have a series of a dozen, maybe a dozen and a half test workloads. And these tests, it's a very structured test of workloads. We have mock workloads that test healthy, unhealthy, flaky, slow start, out of memory, and a whole host of other common conditions that we're able to basically push water through the pipe to understand how DeEEP network responds and how resilient it is to these different conditions. One of the difficulties in running workloads is that we don't control the software 100%. So we have to be ready for all of the typical conditions you might experience in a software development lifecycle and be able to react to those in the system and reschedule that workload or other workloads around it depending on the runtime state of these workloads. So that's an overview of the DeEEP network, the stack, and how we think about structured testing, some of the components that are in play. Next, we're going to bring up Ben, our CEO, and dive deeper into the security of the network and how we think about key management. So stay tuned. Hey, if you're still watching, please smash the like button over here, or over here. Smash the like button. This one right here. Smash it.
Tell them to add a comment and share.
Add a comment, like, share the video. Thank you very much. I don't know. Can you piece some of that together?